One of the following deterministic FAs accepts the same language as this non-deterministic FA shown in picture 1. So you have to tell me which one is it. Okay, so here is non-deterministic FA. You need to convert it to a deterministic version. Okay, I will spend some time to go through this, show you exactly how to convert it. Let's make it simple. We label those states. We really need to give each state a name anyway. So let's label them 1, 2, 3. Okay, we normally start from same state. And next thing is we should merge non-deterministic transitions into single transition, so that make it deterministic. With non-deterministic transition, I can see from here I have one go back to 1 itself, that using symbol A. At the same time, I have same symbol A go to state 2. So that makes a non-deterministic. So I have to merge these two into one state. So I have now label my second state, which is not same as this. This state represent both state 1 and 2, and with same symbol A. Does it make sense? So now this transition and that transition, two transitions merged together, is represented like this. So therefore, non-deterministic transition, now I change to deterministic. And next job is I move up to this new state which I just created. I have to go back to check both state 1 and 2 in my non-deterministic version, check which transition they have, and try to copy it down. Now let's look at transition 1 first. Now let's look at state 1. In state 1, I have this again, two A's. Because A's go to 1 and 2, so really I should have something like this. Okay, this transition have A coming back to 1 and 2, which represent again this transition here and this transition here. You might say, why do you have to do it again? Because I already had this 2 represent here, but that's not good enough. This one only represent from the first state. Then from this new state, we really use this state to represent both 1 and 2. So anything going out from state 1 and 2, you have to represent them correctly. Okay, so now we done this 2 transition. Let's move on to the second one. The second state, we examine what we have in second state. Now you can see there is one transition go to 3 using B, and similarly using B you can go back to 1. So with symbol B you will go 1 and 3. That makes something like this. Have B now lead to a new state. It's not 3, not 1, got to be both 3 and 1. Okay, is that clear? Then our last job is checking this new state. Any transition going out from 1 to 3, you should copy them down. Luckily for 3, there's no outgoing transitions, so just look at 1. Then again, we know 1, we have 2, 2 transitions with A. So how to represent this? Now we know A go to 1 and 2, then we have 1 and 2 here. That will be represent as transition like this. Okay, and that's all, because all the transitions is copied down. Our final task is the copy hold state. There is only one hold state, 3. So checking anywhere we have 3. This is place we have 3. Then we mark it as a hold state. Okay, so this would be deterministic FA. to correctly represent this non-deterministic finite automata. Now, using this answer, we go back to my exam paper, checking which one is correct. The first one is incorrect, yeah. So second one, you can see this is one exactly same as this one we just work it out. This one, okay. Then the rest of two are incorrect. Then let me just quickly mark it. Correct answer for this question is C. If you say, well, this is too complicated for me to remember, to take in, I can give you a quick tip on this type of question. What you can do is you can pick up one or two strings from the given finite automata and to check if that strings can be accepted by the choices I gave you. The point here is they should be exactly same language. So any string accepted by this one should be accepted by the correct one. Yeah. Let's see. For this one, I just quickly pick up a simple example like A, B is a string accepted by this given finite automata. Now you can quickly examine which of those language accept AB, which one does it? Does it not? Okay. The first one is really immediately you can see it doesn't accept AB because if you go A, there's no transition for B. Let you go carry on. Oh, B is here. There's one A and B is okay, but this is not hold state. So AB is not accepted by this one. And the second one, A, B, yeah, it's also stuck in the middle. You can't go to hold state. Then the last one, where does it go? A, loop, and B. There's no way, yeah, to accept A, B. So therefore, only this one, the choice C, will lead you to hold state. So A, B. Okay, that is just a simple tip. And if I gave you a similar sort of question, you can use this method. Find a few simple strings and check against with all choices. Okay, then you can eliminate incorrect ones. And finally, you can identify which one is correct. But really, I really want you to understand this process, which I just show you, the converting things. If you can do both, that'll be brilliant. But if you think first one is too difficult, you can use my second approach.